Hey guys, Mr. Priding here to give you the first lecture in the energy and motion unit. The physics talk, and there's only one, is law of conservation of energy. And the very first part, it's kind of talking about a ball. If you're throwing it up and it's coming back down, you're having a bunch of energy transformations. First, you throw it up, you put work into the ball, and the ball goes up and it slowly will slow down and then eventually come to a stop. And then at the very top of that, it's going to have a lot of potential energy, but we know that's not where it stops. It comes back down, and theoretically, in a perfect situation, it should have the exact same velocity at the bottom when it comes down as when it left our hand. The reason why is because the amount of work we put into it, it's going to gain that much potential energy, and that potential energy then will become the kinetic energy again. Now we know in a perfect world, there is no such thing as a perfect world, and so there's other energy transformations that go on there, such as the friction between the ball and the air. And so whenever we look at real world situations, all of the energy that we started with over here, we're not going to end with that, so it's not going to end with the exact same velocity on the other side. But theoretically, that's what this thing is saying here, is that the ball does not lose energy. And so that is the law of conservation of energy. Energy is not lost in a system. Now, to understand this concept, the easiest way is to know kinetic and potential energy and to study them and see that there are many transformations that occur between the two, and that when those energy transformations happen, that energy is in fact not lost. And I think, let's see. So yeah, it just continues the sum of kinetic and potential, the total energy. It never changes. So if you start off with 100 joules of energy between both potential and kinetic, you will always have 100 joules of energy. At the very, very top, we know that all 100 joules are going to be potential energy, and then at the very bottom, when it's rushing its way down, then most or all of that energy is going to become kinetic energy. And that pretty much ends the first lecture. If you have any questions, make sure you write them down and ask them in class. Other than that, I will see you in lecture 2.